So, hypotenuse leg, okay, is our last like triangle congruence, and then we're going to look at something that kind of is related to triangle congruence called CPCTC, and I'll tell you what that means here in just a second. But let's worry first about these hypotenuse leg style problems, okay? So in this case, first of all, what kind of triangle must you have in order to be able to do a hypotenuse leg proof? It's got to be a right triangle. It's got to be a right triangle because only right triangles have a hypotenuse and a leg. So it must be a right triangle. Did I hear a question? No? Okay. Must be a right triangle. Okay? Now, let me say this as well, okay? Just because you see a right triangle does not mean it's a hypotenuse leg proof, right? Because we just saw an example of that earlier. Well, I don't have it with me. But we just saw an example of it in our homework, right, where we had right triangles, but they weren't proved congruent by hypotenuse leg. They were proved congruent by, I think it was angle side angle. Yes, yeah, or angle side, one of those two, yeah. So either way, it was not necessarily hypotenuse leg. So just because you see a right angle does not necessarily mean it's hypotenuse leg, but we could use it. So here, okay, we see some right angles in our triangle, so we could use hypotenuse leg. Now you guys know, because it's in the notes for hypotenuse leg, it's going to be hypotenuse leg, but you know, that doesn't mean it will always be that way, right? So keep that in mind. Okay, so first step here should be tailor what? What's going to be our first step? Write the given information down. You got it. So step 1, measure of angle MPQ is equal to the measure of angle MNQ equals 90 degrees. And segment MN is congruent to segment PQ.
So how would you mark those two angles, the first two that you given?
Okay, yep, I'll talk about that in 1 second. Let me just finish right in here. The given is our reason, right? It was given to us. Okay, so you're talking... So there's the given information written down, so I can zoom in just a little bit there. There we go. Okay, so the first pieces of information, we're told that the measure of angle MPQ, so let's identify MPQ. There's MPQ, so that's this angle we're talking about, right? MPQ, so it's this angle. So it's already marked 90 degrees for us, which is nice. Okay, let's see, MNQ, MNQ, so there it's this angle right here. Also marked for already marked for us. And then MN, segment MN is congruent to segment PQ. So in that case, what do we got to do? We just have to go over here's MN, right? And that's going to be congruent to segment PQ.
Does it mean congruent when it says measure MPQ equals M?
That's the idea, yeah, is that they're they'll also be congruent. If they're the same, if an angle is the same measure, they're also going to be congruent.
So congruent is equal to?
It's a similar idea. When you talk about the word equal, you're talking about like measurements of something, right? So like if you measure an angle, that then is equal to 90 degrees or equal to whatever the degree measure is. But if you're saying two things are congruent, yes, they will be equal in measure, but they'll also be equal in like size and shape and stuff like that too. So slightly different, but it's a very similar kind of concept. Very similar kind of concept. Okay. So if you look here, okay, we got MN and PQ, okay, is that a hypotenuse or is that a leg of our right triangle here? So for example, MN, is that a leg or hypotenuse? It's a leg. How do you know it's a leg, by the way? What makes it a leg? It's not two lines together. So, yes, that's one way to think about it, Julio. So they are touching the right angle. So both MN and NQ are the legs of the right triangle. Okay? The hypotenuse is always opposite which angle? The 90-degree angle, yeah. So MQ here would be the hypotenuse for this triangle. Okay? So we have hypotenuse leg. This is what we're going to try and do here, it looks like, because we already have one pair of legs congruent. So let's see, what else can we say is congruent here based upon our picture? So, okay, but going to this real quick, if you look, right, we already have a congruence here, we already have a congruence here. So it's nothing, there's no information from our given that we can pull a congruence out of. So we have to go to our picture. And so That's what I mean. They're already congruences, though. There's no, like, other information that we then pull a congruence out of. It's already given to us, is what I mean. So, yeah. There.
MQ and MQ?
Yeah, there you go. MQ and MQ. Okay. I was sure Jaden was going to raise her hand for that one, but she was probably just like, I'll let someone else give it a shot, right? Okay. So anyway, and that is the reflexive property. Okay, reflexive property. And so now, because I've shown those congruent, I'm going to mark on my picture that MQ is congruent to MQ like that.
You're finished now.
Yeah, that's it. We're done. We've got our congruence. Okay, so for our third step here, let me go to Xander again. So Xander, I've got all the information I need. Now I'm ready to say the triangles are congruent. So what should I list here for my last step? Okay, so MNQ. Oh, MPQ? Okay, sorry, I didn't hear you. Sorry, MPQ, I was going to say, okay, is congruent to what? Okay, so be careful here. MPQ, okay, so see how it's named? This top triangle here is named MPQ, okay? It should then start with, for this triangle, it should start with a Q, then go to the N, then go to the M, okay? It's very important we are careful. The first triangle you can name however you want. The second triangle you have to name so that corresponding parts match up. Now, Xander, if that's something you're like, I don't really feel confident about like doing that on my own, just always use the proved there. Just always use that, and you'll always have it in the right order, because they'll give it to you. You'll be given it in the right order there. So just use that one, okay? All right, and then what's the reason, Xander, how we know that those two things are congruent? What's our congruence? What's our statement? Is it ASA, SSS? What is this? So if you look here, it does look like side, angle, side, kind of like that. But if it was side, angle, side, it would be side, angle, and it would have to be this side, which we don't know. So it's not that.
So it would be like...
Side angle.
Side, angle? So you think that, right?
HL.
It's hypotenuse leg.
Oh.
It's hypotenuse leg. Remember, side, side, angle is also the same as angle, side, side, which is not a congruence. Right? Not a congruence. So if you're writing out bad words on your paper, or bad words backwards on your paper, you know that you're doing it wrong, because you cannot do...
So, because if you're like looking at it,
Yeah.
you're like, well, what is it? And you're like, ASS, and you're like, wait a minute, that's not
Well, so
one.
Derek's right. He's right. It is angle, side, side, but it's because it's the right angle we have to use hypotenuse leg. That's the real thing here.
Well then, I mean, there are other triangles with right angles. Why aren't they hypotenuse leg?
Because sometimes we have other information given to us. Sometimes we don't have the hypotenuse and a leg congruent. Sometimes it's both legs congruent to both legs, kind of thing. And that would be side, angle, side.
Well, like, for example, if you go back on this paper...
Yep, exactly.
The first problem is hypotenuse leg.
First problem's not. There's no right angle in that triangle. The third one is...
Then why didn't we label it like that?
Because look at how the information was organized. Let me get that paper. Hang
What do you
on.
mean how it's organized?
Or how the information was given. Okay, if I go back to the homework from last night, okay, looking at the information that we have here, we do have the two hypotenuses congruent, right? Yes, Ramon? Yes.
What's a hypotenuse?
The hypotenuse is the side opposite the right angle,
Okay.
and the right triangle only, obviously, because it's right angle. We do have the hypotenuse congruent, but do we have any legs congruent? No. So we can't use hypotenuse leg here, even though it's a right triangle. That's what I was trying to say earlier. Just because it's a right triangle doesn't mean you're going to use hypotenuse leg, okay? But if it is a right triangle, you could use hypotenuse leg. So here, okay, it would be angle, angle, side, because you have these two angles, right, and then the side out, not between them, but, you know, next to them. So it's angle, angle, side. So does that make sense now? You kind of see that?
Yeah.
Okay, good. All right, let's try another one here. Let's try the next one. Okay, so here we got some more information given to us. Okay, so let's see here. Well, we're going to start with our given. So KL is, what does this symbol mean again? Perpendicular. Okay, and what does it mean to be perpendicular? Come on, Ramel, this is not time to dance.
Is it like you have a right angle? Isn't that what perpendicular is?
Right, it's when the two segments meet at a right angle. Exactly right. When the two segments meet at a right angle. Okay, so JK is congruent to KM. I'm going to mark that in because that's given to us. So the first one, so if they make a right angle, let's identify those. So here's KL, here's JM. So how do you think we should label that? How do you label right angles in a picture? Yeah, the little square where the two things meet. Yep, so you put one there and one there. What's that?
I've seen them on papers too that aren't equal.
I do that just so you so that it doesn't look like a little that kind of like separates the two things, so you like don't think it's one shape altogether. You know what I mean? That's why I do it differently, sides like that.
I do two different shapes, but they're like flat.
Okay, and like I just want to make sure that none of my students are confused. Like, wait, what's that rectangle looking thing? You know?
No, I just wanted to know if that was like kind of like telling you to do it.
Yeah. I got you. Okay. So there you go. Okay. So Ramel, this side JK here, okay, it's opposite the right angle. So what part of a right triangle is that? What do we call that when it's the side opposite the right angle? Do you remember what that's called? I know we haven't talked about right angles a whole lot. We just kind of talked about it today. Okay. Remember, we're trying to prove these two triangles congruent here using hypotenuse leg. So if it's the side opposite the right angle, is that the hypotenuse or is that the leg of a right triangle? It's hypotenuse, that's right. So, Ramel, do you see anything else that we can name congruent here between these two triangles? JM?
Oh, wait, no.
Not sure? Can't see anything? Alright, let me get someone else to give it a shot. Hang on. Evan, what do you say? How about, is there anything here that we can say is congruent between these two triangles? So let me say this. We've already got a perpendicular here, so we've got right angles. We already have these two sides congruent. Looking at the picture here, though, is there anything that we can say is congruent between those two triangles? Which two angles? The two right angles here? Okay, so yep, they're congruent. We could say that, so I'll go ahead. I'll say that. Can you name one of these angles for me? Like, what would this angle's name be? So we sometimes we want to just say L, and sometimes we can just use a single letter. But if we say just L here, yeah, because there's like two different angles going on there. So can you name? So let's name this angle. Close. KLJ. Yeah, exactly right. Must be congruent to. Can you name the other one for me then? Beautiful. Very good. Okay, those two are congruent, and you can say, a lot of things. You can say like both are right angles or both are 90 degrees. However you want to say that there. Okay, there's one other congruent we can see here, though. Hang on, I want to see if I can get someone else. I haven't heard from. I know. Man, I have a lot of people out, so I'm having to run around here. Jason's not here either. Xander, we already talked to. All right, so Skylar, I know we already talked to you, but I'm going to call on you there. So. Okay, so we're thinking that. What would be our reason for that, though? Do we know that? Where it's perpendicular, and it looks like it's going through the middle, but we're not told it's like a perpendicular bisector. If we were told that KL was a perpendicular bisector of JM, then we could say that. But all we're told that they're perpendicular, not necessarily bisecting, cutting into two equal parts. So we can't say necessarily that JL is congruent to LM there. All right, Derek, what's going on?
I was thinking the angles KJL and KML.
These two right here?
Yeah.
That would actually be true. Do you know why, though?
Well, wouldn't it be because the sides are equal?
Yeah. Okay, so that's true. That is actually true. I'm trying to think here. All right, so let's hold off on that. But you're right, Derek. Very good, actually. That's really good. Yeah. Okay. But there's one other one here that I think is, but you're right. So I'll come back to that.
Hey, Alex.
That's what I was looking for there. The guys, we're sharing a side here.
So what was Derek saying?
I'll come back to his. He came up with a really good one there that we haven't actually really gone over very much, but that's really good. Good observation. And so that's the reflexive property. Both are 90 degrees. Or you can say both are right angles, whatever you want to say there. I mean, something along those lines. Okay, now, with that being said, we now have that, And if we say that KL, which is part of this triangle, what is KL? It's a hypotenuse or a leg? It's a leg, right? And it's congruent to this other leg here, so we're actually done. I'm going to come back to Derek's thing once we finish this proof, because he's exactly right about what he said. So, last step here, okay, and so Xander, how should we name these two triangles? Sorry, I'm looking here. KJLKML. Okay, that works, yep, if you want to name it that. Or you can also just use the name given to it here. But he's not wrong. KJL would work, is congruent to KML. That should work. And yes, this is hypotenuse leg.
So how do you know that?
How do you know that? We have right angles, so these are right triangles.
Okay.
This is the hypotenuse. It's congruent to that hypotenuse. And this leg is shared by both triangles, so it's congruent for both.
You could also call it,
Right, not angle side side. So basically this, if it's angle side side in a right triangle, then it's hypotenuse leg. That's what we use, hypotenuse leg. If it's angle side side in a non-right triangle, it's not congruent.
and that's what I tried to say in the first problem, and then you were like, no.
But you don't say angle side side, you say hypotenuse leg. Just to be clear. In a right triangle, yes. And any other triangle, it's not congruent then. Angle side side is not a congruence in any other kind of triangle except for a right triangle.
Okay, so like, if you have a problem, and if it doesn't have a right angle,
Yeah.
and it's angle side side, then it's not congruent.
Correct.
But
Yes.
if you have a picture in front of you that has a
Right
right angle,
triangles.
and it's angle side side or side side angle, it's HL.
HL, exactly right.
Okay,
Yes.
that's
Yes.
what I tried.
Yes, okay, sorry, that's right. Now, let's go back to Derek's thing here. Derek is exactly right. These two angles here, okay, are congruent, must be congruent. Because what kind of overall triangle is this big triangle here, JKM?
Equilateral.
Not necessarily equilateral, based on how we have it marked. No, the big triangle here.
Oh, acute.
Okay, so it's probably acute, it looks acute. I'm talking about by its sides, though. What is this big triangle by its sides? Not equilateral. We don't know about this third side. All we see, hang on, by its sides, we only see two congruent sides here. Isosceles. This triangle is isosceles. Now, we haven't gotten to this yet, but I think if not tomorrow, then Friday, we will look at isosceles triangles. And we kind of talked about it, right? If these two sides are congruent, the angles opposite them must also be congruent. So Derek is exactly right in his reasoning there. These two angles would be then congruent, which, with that, we now have a couple options here. We could say angle, angle, side, okay? It's another possible way to name those two things congruent. Okay, we would have to, of course, say these are congruent here, and then say angle, side, angle, side there. But that's true. So good job there, Derek. Good eyes. So either one would work here, yes. But we would have to list. So to do the angle, angle, side, we have to list. I'll kind of put this in like parentheses here. We could say, or I could put this, or we would do step 4 to be angle J. And here, Evan, right, we can just use the single letter because J only has one angle at it, so that's okay. And angle M is also okay. And the reason for that is because, I think it's called like the isosceles base angles are congruent. Or something like that. That's like maybe like a succinct way to put it. And then step 5 would be, triangle, same thing, triangle KJL is congruent to triangle KML. And then the kind of 5th step would have to be because of angle, angle, side.
So for number 4, what you should, well, not number 4, but number 4.
My number 4 in parentheses there?
Yeah.
Okay.
That, won't actually be a step that we have to do.
No, I mean, you're done here. You could stop here and do hypotenuse leg, but if you use what Derek did...
Let's say the hypotenuse leg, the KJL.
Yeah.
So let's say KL equals congruent to KL. Let's say that wasn't there. Would you have to put that other one that Derek said?
So if we didn't use this one...
let's say that's 9.
Then, yeah, you'd have to use Derek's. You'd have to use Derek's, yes.
But that won't be on our test. Something like that.
No, I don't think so, because then you would also potentially, if this wasn't true, then you would also potentially lose this as well. You wouldn't necessarily have that as well, because the picture would have to be altered, and it might not be an isosceles triangle anymore. Okay, last one. Now, what is different over here than our normal proofs? What's kind of like a different kind of thing over here in our given or prove information than what our normal proves? Yeah, the thing we're trying to prove. Look what we're trying to prove here. Are we trying to prove two triangles congruent?
No.
No, we're trying to prove two segments congruent. And specifically, we're trying to prove that this segment is congruent to this segment. Now, you'll notice, though, that AB is part of a triangle right here, right? And CD is part of a triangle here. And in fact, if we were able to show that this triangle was congruent to this triangle, what would AB in this triangle, what would AB match up with over here? CD, okay? So, this kind of proof is the same, like what you see here when you have two triangles and you're trying to prove a part of those two triangles congruent. This is what we call a CPCTC proof. Why is it called CPCTC? Because it stands for corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent, oops, and I missed the word triangles. Corresponding parts of congruent triangles are congruent. Now, what does that even mean? Well, basically the idea here is to show that AB is congruent to CD, we're going to follow the normal steps of showing these two triangles to be congruent. Okay? Once we've shown that this triangle is congruent to this triangle, then we just add one more step on and say that, oh, then if these two triangles are congruent, then AB must be congruent to CD because, and our reason will be, corresponding parts, matching parts of congruent triangles must also be congruent.
So
Okay?
like when your proof is something not like...
Not a triangle congruence.
So that...
You still prove the triangle is congruent, but then you have one additional step, and it's going to be that.
I know, I'm saying that your proof, since it's different...
Yes.
Is that automatically CPC?
Exactly. When you see your proof is not two triangles, but two parts of a triangle, then you know it's going to be a CPCTC proof, hands down. Okay? Corresponding parts of congruent triangles are congruent. Okay, so let's start this thing. Let's do this one. Okay, so we've got AB is parallel to CD, and BC is parallel to DA. Okay, and of course that stuff is given to us. Now you'll notice here, we are not given any congruences in that given information, but we're told they're parallel, so let's mark them parallel. So let's see, AB here we'll mark as parallel to CD, using the little arrows, and then BC is congruent to, or sorry, not congruent, parallel to DA, like so. Okay? Nah. You normally want to put them in the same direction as each other, so if you put this one as a down arrow, this one should be a down arrow as well. Okay? All right.
So could you do BD now?
Okay, so okay, go ahead. What do you want to say there?
Okay, so would you do segment BD is congruent to BD?
Yeah, so hopefully everyone here can see that BD we can say is congruent to BD, right? It's shared, it's reflexive, okay? So that's something we can definitely mark as being congruent, so I'll go ahead and mark that in there. That's one congruence. But we still need to come up with two more here, don't we? Well, because first thing we have to do here, Skylar, right, is to show the two triangles congruent, and then for our last step, we put in what we're trying to prove there, that AB is congruent to CD, CPCTC. So we still are doing a triangle congruence. oh, no, sorry. Yeah, we had to come up with two more congruences, because we're not done yet, right? So, what else can we say is congruent here? How can we use these parallel lines to help us? We saw a parallel line one yesterday. Okay, so yeah, Skylar, you remember here? So let's start with this. We have BC, and it's parallel to AD, and I'll give you a hint here. These two parallel lines are cut by a transversal. Yeah, kind of. You call this a I mean, it's also called a diagonal. It depends, but you can think of it this way, right? A parallel line's cut by a transversal. So remember when we did that in the past, when we had parallel lines cut by a transversal, we created some congruent angles, right? We had different angle relationships. We had like alternate exterior, alternate interior, co-interior, corresponding, all that kind of stuff. With the way our picture's drawn here, if this is parallel to this, we have a transversal here. What kind of special angle pair do we have?
Isn't it
Yep.
BC is congruent to AB because it has to be like the same length because it's connected to BD.
I see what you're saying there, and so like, I think that you're going to be right there. But the reason we don't have like you're right, like the intuitive like geometric sense of you, that's right. It's going to be equal. But the reason we don't have a reason for that just yet, except for like it looks like it should be true, and it feels like it should be true, and it is true, right? But we can't just use that as a reason. However, let me go ahead and mark one in here. Let's look at this angle. What must angle CBD be congruent to?
Angle DAB.
Their alternate interior, so CBD, this angle, must be congruent to what other
The
angle?
one beside it.
DAB.
Careful, DAB, you're talking about this one. Be careful how you name it. ADB, beautiful, exactly right, this one. They're alternate interior angles, right? Here's the transversal. These two are on opposite sides of the transversal, and they're between the two parallel lines, so they're alternate interior. So, yes.
Is it the same as A and C because they're alternate exterior? Or not exterior, but are they alternate
So,
interior?
see, here's the problem. This angle A is on this transversal. This angle C is on another transversal. They need to share the same transversal.
Could you do like the other angle for B?
Yes. Yes, exactly right. Yes. Yes. So, CBD, let me say that real quick here. Angle CBD is congruent to angle ADB, and that's because alternate interior angles are congruent. I'm going to just abbreviate here. So, alt, int, right, R, I'm going to even use the congruent symbol rather than the word.
Wouldn't you think that the other angle beside B is...
Yes, and that's exactly what Haley just said. Exactly right. Yes, because both pairs of opposite sides are parallel. We also have these two pairs of congruent angles. So exactly right. Okay, very good. So we got to name them though, right? This is the trickier part. We got to name these things. And so how would we name those? Julio. How could I name this angle, Julio? Name a side of this angle. AB, and then where does it have to go to the next side? D. ABD. That's it. Okay, you understand what I'm saying now? Okay, so what's this angle's name then, Julio, right here?
BDC.
BDC. You got it. And again, it's because alternate interior angles, and I forgot the word angles in the previous step, whoopsies, are congruent.
Is it okay if my,
Excuse me.
if I said ABD is congruent to CDB?
ADB is congruent to C. For number 3?
No, number 4.
4? So you have ABD, you said was CDB? That's fine. Yep. The first and last letters for the angle name don't matter, it's that middle one that matters. Okay? Alright, let me see if I can get someone here we haven't heard from. Alright, how about Ryan? So we've got 3 congruences here. What triangle congruence then do we have? Is it hypotenuse leg? Is it side, side, side? What do you see here? Yes, it is. Very good. Okay. So, whoops. So, step 5, we're gonna name these 2 triangles congruent. This is not as easy as before. Why? The triangles are not listed for us already. So now we have to be careful how we list these triangles, right? So, Ryan, would you be willing to do that for me here? So, this first triangle. Why don't you name the first triangle here? The first one doesn't matter the order, so you can do whatever order you want for this one. BAD, you got it. Triangle BAD is congruent to, now, triangle. Now, angle B for this triangle, angle B has to match with what angle over here? So look how B is marked. Angle B for this triangle has to match with what triangle over here, or what angle over here? It's marked with, it's congruent to the D, right here. There's the angle D for that triangle, so it's got to be D that it matches up with. Okay? Sorry?
That's it?
Well, we're not done yet, no. And then B to A, okay, what does A correspond to, Ryan, in this other triangle? What does angle A match up with in this other triangle here? Very good, C. Okay, and then angle D in this triangle, matches up with what angle in this triangle? B. Very good. You got it, Ryan. Great job. And again, you're right. It's because of angle, side angle. They're congruent. Okay? So that step gets a little bit trickier because now you have to name the triangles accurately. Okay? Yeah.
Can't you do BCD?
Yeah, you can say BCD is congruent to DAB.
No, because if you have BAD, right?
Oh, if you name it BAD.
Right, so then you like flip rotate your triangle.
Yep.
So it would be...
B would rotate to the
It would
D.
be BCD. Because...
No, because the angle B in this triangle is not the same as the angle B in this triangle. You see? They're not the same. So you can't say that B is going to be in the same position as B. Okay, so again, you're trying to say that angle BAD, or triangle BAD, you want to say BCD? Yes?
Yeah.
Okay, so yes, the A and the C do match up. But the angle B for this triangle, notice it has two congruency arcs there, right? But the angle B in this triangle only has one congruency arc. So we don't know that those two things can be the same. Okay? Yeah. Right, because we're not done yet. If we were trying to prove the triangle's congruent, we would be done. But we're not trying to prove the triangle's congruent, we're now trying to prove parts congruent. So the last step now is to show that now that we've shown the triangle's congruent, then their corresponding parts will be congruent. So we can finally then say, aha, since the two triangles completely are the same triangle, we can now say that AB is congruent to CD, and the reason is CPCTC. Corresponding parts, these are the corresponding parts of congruent triangles are congruent. Yeah, that's what it stands for. Corresponding parts of congruent triangles are congruent.
So how do you tell...
No, yeah, that's what it stands for. It's an acronym.
So the way you can... So like, all the ones on the back, they're not CPC.
So, well, first of all, let me finish with, make sure everyone's okay with this, and then we'll flip over to the back, okay, and we'll identify that.
Alright, I just want to make sure I'm right.
No, I understand. I hear you. Okay, let's flip it over. We're good? Oh, Jordan's just finishing up there. Okay. Ramel, you got it? Okay. So, yeah, get that down. Any questions before we flip over? Any questions on this before we flip over? Okay. Can I flip it, Ramel? Are you still working? You're good? Okay, great. Thank you. All right, flipping over to the back. Okay. The first proof here on the back. Is it going to be a CPCTC? Yeah. Why, Ryan? What are we trying to prove congruent? What things? Angles. So that's part of these two triangles. Okay? So this is going to be a CPCTC proof. Okay? So that means you still try and prove the two triangles congruent, and then for the very last step, the new last step, okay, after you prove the two triangles congruent, the last step is going to be these two angles must be congruent because corresponding parts of congruent triangles are congruent. Okay? What about this one? Is this going to be CPCTC?
Yeah.
Yeah. How do you know, Derek?
Because it's still angles.
Because we're trying to prove two parts of the triangle's congruent. So this will also be CPCTC. Okay? How about the third one here? Is this CPCTC? No. How do you know? We're proving triangles congruent. So this is probably going to be a hypotenuse leg then, because that's the only other one we saw. Okay? Now you'll notice, when we did the CPCTC one on the front, I didn't use hypotenuse leg here. We ended up using angle side angle. So for these two CPCTCs, you might not use hypotenuse leg. It could be like your side, your angle side angle, your angle side. So keep your eyes out for that, okay? These are just kind of like two general proofs, okay, for the top and the bottom one there. All right, questions on any of that? All right, so this is what I want you to work on for the rest of class. Yeah, Scott? It's going to be a CPCTC because we're trying to prove two parts congruent there. Okay, notice, guys, there's parallel lines here. This proof, I will give you a hint, is going to be very similar to the one we just did because it's also talking about two sets of parallel sides there. Probably an HL because it's, again, two triangles are congruent. You're talking about perpendicular stuff there, so yeah. Because what is it? So what does CPCTC mean? What do we use it for? We use it to show parts of triangles are congruent. Here in our prove, what's it asking us to prove? Parts, angles in this case. So the second one, parts, angles. And which one? Well, look at the piece of given information that you're getting. Oh wait, for which one are you talking about? For the second one? Right, so these might not be hypotenuse leg triangles, they might be side, 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 angle, side, something like that. So you have to, when you mark your information there, you'll have to come up with what the congruence is. These are a little bit tougher because, yeah, it's not given to you what you're looking for necessarily. So anyway, get to work on these. I'll come around and help as necessary.